Hi, I'm Romano Petrocchi, a PhD candidate in AI ethics at the University of Macerata, and welcome to my first class of the course Technology and Digitalization of Civic Participation. I'm going to share the slide of this class, and then we can start. All right. Today we're going to talk about artificial intelligence and its implication on society. This is an introductory class, so we will introduce the concept of artificial intelligence, what AI is, how it works, and then we will also try to outline the kind of data on which AI systems are built on, and then the types of data that AI systems collect, gather, and exploit. After that, we will see how artificial intelligence systems can empower recommender engines, and then how they act as an invisible engine. And after that, we will analyze the relationship, the natural relationship between artificial intelligence and citizenship, and we'll conclude by outlining some future directions and by defining the importance of digital literacy. So, section 1, artificial intelligence systems and introduction. What is artificial intelligence, and how many kind of artificial intelligence there are there? So artificial intelligence is the science of creating machines and programs that can perform tasks that normally require human intelligence. And there are two main types of AI systems: rule-based AI, let's say, that are also called white box, and learning-based AI, also called black boxes. So rule-based AI systems work with fixed human written rules, for example, the if-then logic, and they are good for structured, repetitive problems. An example is a medical expert systems that diagnoses diseases using a decision tree that is a simple model that doesn't entail any kind of machine or deep learning systems. While learning-based AI learning-based AI systems refer to machine learning and deep learning techniques, and these kind of systems learns from data and experience, not just following some rules. And these systems can adapt and improve over time. An example is a very known digital platform like Netflix that suggests movies based on what user, for example, have already watched. What is machine learning then? Machine learning is a subset of AI where models learn patterns from data rather than following explicitly programmed instructions. And machine learning is based on statistical methods that aim at optimizing prediction or classification tasks. An example is a spam filter that is trained on a data set of previous emails. While deep learning is a subfield of machine learning that exploit multi-layered artificial neural networks. And deep learning is effective with unstructured data, such as images, audio, recordings, natural languages, and this kind of artificial neural networks might be convolutional neural networks or recurrent neural networks or transformers, are the architectures exploited by deep learning techniques. An example is an image recognition in self-driving cars. So these kind of systems for autonomous driving has the goal of recognizing the images that are not already known, because it needs to recognize the environment in which the car is driving and then adapt considering on the basis of this environment. Another example is a speech recognition system for virtual assistants. And so also in this case, the model should recognize the different voices, the different words, the different way of speaking of different people. And so in this sense, the data are unstructured because are not predefined and are not even the same of the ones in which the system has been trained on. Neural networks are, as I said, the structure on which exploited by deep learning models. They are composed of layers of nodes that are called neurons because artificial neural networks are inspired by biological neural networks, and so also there is this let's say similarity on terms. But these neural networks are the artificial ones are built on this structure. There is an input layer that receives raw data, such as pixels of an image. And then there are hidden layers that extract features via weighted combination of, for example, nonlinear transformations. And then there is an output layer that produces the final prediction and the final output. There are these two important concepts that are forward propagation, describing how data moves from input to the output while being transformed, and then back propagation instead, that explains and represents how the model can adjust the internal weights based on prediction error. This is a visual representation of how a neural networks is structured. There is the input layer and the hidden layers, and then the output layers. And you can say how many combinations are present between the nodes, between the neurons. And this is why this is why all these kind of combinations are the reason why deep learning models are considered black boxes, because it is extremely difficult to understand all the inferences and all the correlations that a model makes. We can make an example, an applicative example for explaining how these neural networks works. Let's say that we have a neural network for recognizing handwritten digits using NIST dataset. That is one of the most famous dataset and used dataset. And it represents a collection of 70,000 handwritten digits. So the inputs is an image of a digit. And then what the AI learns to do, it's look at the image and predict the number that is written on the image. So this is one of the simplest and most classic example of AI, and it explains how the AI systems are able to see the images and then learn from patterns in data. So to explain in a simpler way this concept, you have to think of each layer as a filter, and the first detects the edges, the next detects the shapes, and the final layer identifies the digit. And yeah, artificial intelligence is in our everyday life. For example, in social media, AI decides which posts appear first in our feed. It learns from our likes, share, and what we previously watched. An example is Instagram, that shows more of what we engaged with. So like videos about cooking or sports that can appear even if we never directly searched for cooking videos, okay? Because by learning patterns in data, the algorithms can identify what we like and then propose suggested content similar to what we like. Another example is online shopping, such as Amazon or Zalando websites, AI systems can suggest products that we might like based on our past views and purchases, but also they can suggest items based on what the system infer about our preferences. An example is that the category people who bought this item also bought these and that items. And this is present in Amazon and Zalando websites, as I said. But also on Google and other search engines, AI helps understand what people are looking for and then shows the most useful results. AI finishes also our search as when we type, there is this auto completion function. An example is typing weather, and then the algorithm shows our local forecast because it understood and it learned where we live, what we usually look for, and the weather in which cities. So this also goes for smart assistants. AI allows them to understand our voice, to learn our voice, and then they can answer our questions. They can set reminders or control smart devices. Yeah, the example of Siri is the most famous. There is Siri, what is the weather tomorrow? And this is a combination also of search engines and smart assistants, because if we ask Siri what is the weather tomorrow, Siri is going to respond. It's going to answer how is the weather in our town. And so AI works behind the scenes in many tools we use, and it's useful because it helps us find what we want to stay connected and make our life easier. But there are also some influences that we see. It influences what we see and what we do. This brings us to our second section, how AI works. How it is possible for AI systems to understand and to learn the data, to learn what we like, and to suggest new things related to what we liked. And this is possible because AI systems have a statistical nature. So they don't understand the world as we do, but they rely on mathematical models to identify patterns in large data sets. So these patterns are usually correlation. They are not based on the cause-effect relationship, that is the way in which the human intelligence works. But by analyzing these large data sets, then AI systems are able to find invisible patterns, to find correlations. And indeed, AI finds associations like user who clicked on on A also clicked on B. This is not a causal effect relationship, but it has a statistical probability to be true. So if you clicked on A, for example, you might also like B. And this is just an association, is not causation. But indeed, this artificial intelligence is not able to explain why things happen and what is the deeper meaning of this association, of this correlation. An example might be that the AI system predicts that people want to listen to classical music, that the people who listen to classical music are more likely to buy high-end coffee, and then it may recommend coffee ads to classical music listeners. But there is no possibility that these AI systems is able to explain the reason of this correlation. So AI works is very powerful and is super capable of recognizing patterns within data. So it tells us what often happens together, but not why. And the risk, this entails a big risk of misinterpretation, because AI presents data-driven outputs with confidence, and user may assume that the results are true, objective truths, because the results, by being truth, can be considered objective truths. But these risks include treating correlation as if they were causes, over-trusting AI-generated prediction, and ignoring social, cultural, and emotional context. A real-world example is hiring algorithm that finds that past successful employees were mostly men, and then it begins to favor male candidates. But this might reflect past hiring biases and not real merit. And so the implication is that even if the AI output is accurate, it might exacerbate and reinforce inequalities, social inequalities. And then if it not used with critical oversight, then this exacerbation is going to be part of our exacerbation of inequalities is going to be part of our society. We can consider the case studies that I invented, Claire and algorithmic bias. The Claire story is that Claire lives in a community where certain stereotypes are common, and so she clicks on content that reflects these views. Of course, the algorithms are going to learn from her clicks and shows her more of the same contents, and the result is that the Claire's feed becomes an echo chamber, so an environment in which the same content is always repeated, is always proposed, and Claire is going to receive little exposure to alternative views and new perspective. And of course, the conclusion is that her opinions will be reinforced by the content that she sees, and these opinions are not going to be challenged. And in class 3, we are going to deepen the concept of echo chamber, because is one of the most debated and important consequences of AI systems. But why this matters? Because AI shapes what Claire sees, reads, and believes, and her digital world then narrows, even though she thinks that is freely exploring it. So AI doesn't have any specific agenda, but it is designed to maximize engagement, but often leads to reinforcing user biases. So we see that by relying on correlation, then deep social consequences might arise. And the problem is that users tend to trust AI-generated results. If the algorithm say it must be true. And this is not always correct, because we always be aware that AI output are based on correlation and not in cause-effect relationships. And so the lack of causal reasoning is important, because AI rarely can explain why something is recommended. So users don't question the reasoning behind the content or decision, and this is one of the main problems concerning the relationship between AI and humans. And yeah, another example is the newsfeed algorithm that might recommend emotionally charged stories, not because they are true, but just because they get clicks. Or another example is the health apps that suggest treatments based on past data without understanding, however, the individual context that might be super important for these kind of suggestions. And so the takeaway that we must bear in mind is that developing critical digital literacy to question what AI presents is super important, and understanding that AI gives correlated guesses and not truths is key to using AI system wisely. This brings us to section 3 that relate to the analysis of data, or generally, what kind of data AI uses. And this data can be classified in 3 main categories: explicit data, data that user intentionally provide, such as like, ratings, comments, written reviews, implicit data that are collected by observing user behaviors. An example might be the time spent on a page or the scrolling behavior. And the third type of data is contextual data that are related to the user environment or condition of use, such as time of day, device use, geolocation, and browser type. This matters because each data type helps AI system understand, predict, and influence the user preferences and action. So now we can focus on explicit data. As I said, that are data that is consciously given by the user to the system, and so it reflects in this way deliberate opinions and preferences. So we can click like on a Facebook post, we can give 5 stars to a product on Amazon, or we can write directly a review on TripAdvisor. And these are actions that we are directly making. So in this sense, explicit data. And AI builds create a profile based on these direct data that can be considered as stated preferences of the user, and then trains the recommendation engines to suggest these kind of preferences and then these kind of items. There are some limitations of using just explicit data because users might not always be honest, and a light might not indicate a real interest or intent. So a stated preference might not be a true preference of a person. But this limitation can be overcome by gathering and collecting implicit data. Implicit data are gathered passively by observing how people interact with content. Examples are the time spent watching a YouTube video, pages that we scroll past quickly versus those in which we pause on because maybe those pages represent an interest on the content presented on that page, or links clicked versus link ignored. So detecting what really holds our attention is the goal of collecting implicit data. Implicit data, AI system can uncover hidden preferences or emotional responses. And we can understand now how these kind of data are powerful because hidden preferences might not always be completely aware in the user. And then the system might know the preferences of a user better than the user themselves. And this, of course, can create more accurate recommendations. And also, this matters because can reveal habits that people are not aware of. Contextual data, on the other hand, are data about the context in which we use the platform. Example concerns using a smartphone versus a desktop, or being at home, work, or on holiday, or morning versus late night browsing. And of course, AI system can personalize this content based on context. An example is suggesting different playlists on Spotify depending on time of day or location. And yeah, of course, there are some risks based on that related to privacy and consent, because these kind of data, but also implicit data, are also collected without clear awareness of the users. But how AI systems are able to collect this kind of data? There are many techniques. User behavior analysis is one of them. So it tracks clicks, scroll, pauses, purchases to map the engagement, recommendation systems that use historical data to suggest new content, and navigation patterns that follows how users move to a website or in an app, and helps optimizing layout and predict user goals. Another techniques is sentiment analysis that exploit natural language processing to determine user emotion from text, for example, in reviews, Google. And temporal analysis is another technique that considers when action occur. An example is identifying peak times for shopping or streaming. And so all of these kind of techniques create a super detailed user profile and then enable platform and algorithms on which these platforms are based to deliver hyper-personalized experiences. But of course, there is the dark side of that, because by creating these highly detailed user profiles, then AI systems might risk to manipulate and surveil people. And this brings us to the section 4, AI in recommender engines, because we saw that AI systems are able to collect user data, but how then this data might turn into new recommendation. And this is through recommendation system, of course, because and these are kind of systems that are extremely present in our daily life. They determine what we watch, read, buy, and even believe. And why they matter? Because they shape, of course, our attention on platforms like Netflix, TikTok, Amazon, Spotify. They influence our opinions, our behaviors, and purchasing decisions, and of course can amplify specific content and suppress others. We need to bear in mind that the goal of recommender systems is maximizing engagement. So maximizing the time spent, the time that a user spent on a platform, and for maximizing this engagement, personalization of user experience is extremely important, because if the experience is user tailored, then the user is going to increase the time spent on that platform, and this concept is called user retention. So if we open Netflix, then the first row of suggestion is not random, but it is personalized on our taste and past behaviors. And then this is going to increase the probability that click and watch suggested movies, and then increase the time spent on Netflix. But yeah, how these recommender engines work? We can use the term recommendation or recommender interchangeably. They are the same, and also the literature present these two terms. Recommender systems rely on three main techniques: collaborative filtering, content-based filtering, and reinforcement learning. The first one suggests items based on behavior of similar users. The second one suggests items similar to those that the users have already liked. And the third one learns and adapts in real time, and then create new suggestions based on user interactions like watch time or clicks. And these methods can be used separately or combined into hybrid systems depending on the platform. But understanding these mechanisms is important, because it helps reveal how platforms guide our attention and shape our preferences. Now we can focus on collaborative filtering, because it is important to understand how these kind of platforms can not only gather and collect our data, but also elaborate this data for new suggestions. So collaborative filtering makes recommendations by analyzing similarities between users or items. And it can be distinguished in two types: user-based filtering and item-based filtering. The first one relates to other users. For example, people similar to you liked this kind of this and that, while item-based filtering is that people who like this item also liked these other items. And then you have a combination of your tastes recreated in new suggestions. And this works by comparing your behavior to others, and collaborative filtering finds patterns and uses them to suggest content that you haven't already seen. And so we can understand the strengths of this mechanism because it learns from collective behavior and can recommend items that the users have never directly interacted with. There are some limitations, of course, because it needs a large user base, and it should also cope with what is called the cold start problem, that collaborative filtering doesn't work well for new users or items because the user profile is not completed, is not well structured, and then it's the comparisons with other items, with other users, is more difficult to make. And this is why collaborative filtering is often combined with content-based filtering. The definition is that content-based filtering recommends items similar to those the user already liked based on features. So it works analyzing characteristics of items like author, keywords, or genre, and it builds a profile of the user preferences. Then it suggests content with matching feature. If you like documentaries on space, then the system will recommend other science-related titles. And so the strength of content-based filtering is that it doesn't require data from other uses, because it's just going to extract the feature for making comparisons, and then is good for niche interests. While there are some limitations, because less diversity in recommendations, of course, by learning the features of what you like, is the algorithm based on content-based filtering are going to propose always things in line with your tastes, and then content-based filtering methods can trap the user in the so-called filter bubbles, that are environment in which just the same content are proposed and new perspective cannot enter in the bubble. Then we have maybe the most powerful techniques for recommendation, that is reinforcement learning, which is a machine learning approach where an agent learns by trial and error, receiving rewards for good actions. It can be, of course, applied to recommendation because the system can learn what content keep the user engaged. And it constantly updates its strategy based on real-time feedback, such as clicks, time spent, skips. And it is so powerful because it adapts to user behaviors dynamically, and it learns in this way long-term preferences. Because by adapting to user preferences in real time, then it is able to understand the deep level of your single preferences. There are some risks because it can prioritize addictive or sensational content because they are more likely to catch your attention, and therefore it can lead to manipulative or emotionally charged suggestions. An analogy is can be made with a training of a dog. If the dog gets a treat for sitting, then it learns to sit more often. And this is how reinforcement learning works. We can make two examples, Netflix and TikTok algorithms. Netflix uses a mix of collaborative and content-based filtering and integrates reinforcement learning for real-time personalization. It tracks viewing history, time spent on genres, device type, pausing, rewinding, and skipping. While TikTok makes a heavy use of reinforcement learning and behavioral data and tracks time spent watching each video, rewatches, likes, shares, and comments, and audio, hashtags, and creators you engage with. And then the result is that the more you interact, the more personalized and addictive the content becomes. And of course, both platforms constantly adapt to keep the user watching longer. The takeaway of this is that these algorithms are not just tools. They are very powerful influencers of attention, behavior, and even worldview, because they decide what we see, what we like, maybe even in a deeper way than what we think of ourselves. Because, as I said, they are able to detect and collect our latent preferences, our not well-structured preferences, and then the suggestions and what we are going to watch can, in real time, shape our non-well-defined preferences. And this, of course, makes AI systems as a kind of invisible engine because they shape what we see. We often think that we choose what we see online, but much of it is chosen for us by algorithms, as I said. This means that platforms use AI to decide what appears first in our feed, and then our feed is filtered and not neutral. So we think to AI as something that is neutral, but it is not, because it is based on all these factors and on this data and these techniques. And of course, there are some key factors influencing what we see: our past behaviors, what others, like-minded people, liked, others, similar habits, content, and that increases engagement is also important, because even if we don't like it, even if it doesn't relate to our stated preferences and implicit preferences, maybe it is emotionally charged, and then we are going to watch it. And though all of that make digital platforms environment appears like a neutral environment, but they are super personalized and then the opposite of neutral. I already mentioned these two concepts, filter bubble and echo chambers, because they are implications of these methods. Filter bubble are digital environment where a person only sees the content that aligns with their past behavior or beliefs, while an echo chamber is a space. Yeah, in this sense, we are referring to online spaces where users mostly interact with like-minded individuals. And the causes are that algorithms prioritize familiarity and not diversity, and reinforcement of pre-existing beliefs. The consequences of that, of course, are reduced exposure to opposing views, and we can imagine the political implication of that. Another consequence is the difficulty of recognizing complexity or nuances, and then political and social polarization. AI exerts an influence without awareness. So AI can shape our decision and emotion without us noticing that. How? With small design choices, colors, order, time of, for example, in social media, of posts that are presented to us. And in this sense, AI systems nudge our behavior, and then algorithms test also what works best to keep us, to hold our attention, this A/B testing. And social media notification, for example, are timed to maximize return visits, or newsfeed posts are built to trigger strong emotions. And then the risk is that we believe we are making free choices, but many of these choices are influenced by unseen systems that maximize engagement and not well-being. Of course, by trying to catch and capture our attention then the goal is maximizing engagement and not well-being. Indeed, this new economy is called the attention economy because in today's digital world, attention is currency, and platforms make money by keeping users engaged longer via ads and subscriptions, for example. And so the AI system roles are personalizing content to keep users scrolling, watching, and clicking, and recommends emotionally charged or addictive material. And so we can understand how this is manipulative because there are also manipulation tactics such as sensational headlines, outrage-provoking content, and instant feedback that keep our attention always at the limit. But this entails also some ethical concerns because platforms are optimized for profits, not truth, education, or democratic dialogue. And AI-based platforms, play a growing role in our political communication. Examples of influence, amplifying the misinformation during election or targeting ads based on voters' profiles. But we will delve into these kind of influences in future classes because these, let's say, political implications are extremely important. And so we will delve into any single implication singularly in the next classes. I just want to make this first class an overview of how AI works, the kind of data in which AI is based, and then mention some political implication. I have already mentioned echo chambers that deepen the effect of the influence because users mostly interact with content that they already agree with. And this creates radicalization, mistrust, and erosion of public debate. So AI does not favor any ideology in particular, but it favors what keeps people clicking. This is an important aspect. And as I said, we will look now at the interaction between AI and citizenship, because AI is used in public sector. There are many applications such as predictive policing, welfare distribution, and smart cities. And there are benefits, of course, because these increase efficiency, speed, and resource allocation. But there are also some risks, such as a lack of transparency, potential unfair or biased outcome. These are just some examples of application in which AI is used in our daily life, such as predictive justice. But this presents the risk that data might reflect past biases or black box decisions that cannot make the system accountable for their output, and then violation of human rights and due processes without any specific person to be accountable for. And key questions is that can a mathematical model truly understand context, motive, or fairness? AI is used also in education and healthcare, and there are concerns related to privacy of sensitive data, inequality in access to AI-based tools, and potential dehumanization of care or learning. There are many sorts of biases, of course, in AI systems, and we will delve into that in future classes. There are biased training data, there are lack of diverse design teams, and ambiguous and unfair performance metrics, and these entail and cause extremely discriminatory practices and systems. And of course, the consequences are denial of social benefits and misrepresentation in underrepresented population. So who designed algorithms? Accountability, of course, matters, because those who design AI systems also decide what values, goals, and assumptions the system uses. And the problems are lack of diversity among developers, tech companies that often operate without democratic oversight, and users that rarely know how decisions are made. And so we need clear rules and public accountability, ethical design practices, and citizens' involvement in technology governance. So the takeaway of this section is if AI shapes society, then society must also help shape artificial intelligence systems. And the future directions and digital literacy. Digital literacy is key in the age of AI, in our AI-based society. Digital literacy refers not just to know how to use the technology, but to understand how the technology use the user. The new components of this literacy refers to knowing how algorithm works, questioning information sources, and then recognizing manipulative patterns. It is urgent, of course, because democracies require informed citizens, and the goal is to empower users to navigate these kind of digital platforms and digital environment. We need to teach critical data thinking for a more empowered digital citizenship, the skill to promote interpreting data and statistics with skepticism, identifying biases and missing context, and understanding the difference between correlation and causation. And finally, we need to transform a shift from consumers to citizens. So AI reshapes not only how we live, but how we think and act as citizens. And so the challenge is not just use AI, but understand it. Don't just consume content, but question it. And don't just click, but reflect. So a digital literature, ethically aware and critically engaged democratic society is what we need to achieve. But we will see these implications, these relationships between AI and society in future classes. I hope that that now you have a more clear understanding of how AI systems work and what is AI. So the different types of AI models, machine learning and deep learning based models, how data are collected, and how this data, through which techniques this data can be used to make new suggestions and to produce AI-based outcome. And we pass through some political and ethical implications of AI systems. I want to leave you with 3 final questions. I will provide after the course with the answers, and this is a list of selected papers and books that are important, that are the base of this class. Thank you. I'm going to interrupt the. Okay, stop sharing. See you in class 2.